rather. I say, I wish you'd been with me. I've been to Cowley. You know, where they make Morris cars. It's most awfully interesting.
That doesn't sound frightfully amusing to me. Aren't all these motorworks very dirty and noisy and rather dull?
Oh, not at all. Frankly, I've had a very good time.
Well, you certainly seem to have enjoyed yourself. Tell us all about it. This time before dinner.
Yes, Daddy, do.
Well, you know Oxford. So imagine yourselves driving down that beautiful high street and across Magdalen Bridge. The road to Cowley is the one straight ahead, and it's only a matter of a few minutes before you see the huge Morris factory right out in the country, and not a bit like one's usual idea of a big industrial organization. But once inside the works, you immediately get an impression of intense but orderly activity. One of the first things in the factory to attract your attention is a huge series of racks, lift, to the beginning of what is called the engine sub-assembly line. Each engine is mounted on a separate trolley, so that it runs smoothly and can be handled with ease. The operator draws an engine off the lift and, with his assistant, pushes it through to the beginning of the engine sub-assembly line, where the magneto and carburetor are put on, the sparking plugs are fitted, and all the other auxiliary accessories are put in place, ready for the engine to be mounted. In another section of the factory, you see the back axles being assembled, and everywhere one gets the impression that the labor required from the men is reduced to the practical minimum. The result is that there is no hurry. Every man has one operation to do in which he becomes an expert, and he passes the component on which he has worked up the line to the next man, so that he, in turn, can head his quota of work to the part as it is going through. The maypole at the beginning of the back axle assembly line is a very ingenious device for altering the direction of flow of the components as they move towards the main assembly line. It is most interesting to see the back axle being built up from its constituent parts, and at the end of the line, a pair of dummy wheels are put on, and the back axle is wheeled away to near the main assembly line. The stock of completed back axles, used for one day's output only, is truly an impressive sight when you see them all together, giving a real atmosphere of quantity production. The next thing that is drawn to one's attention is the beginning of the main assembly lines. The genesis of every Morris car consists of attaching the front axle to the chassis frame, on which the running board brackets and step irons have already been mounted. This is really the start of the famous Morris assembly line system. The focus point of the factory, the heart of the works, as you might say, is where the engine and back axle are mounted into the frame. From the engine sub-assembly line, which is on a raised floor, the engine, with rubber-cushioned holding down bolts fitted by the operator, is lowered by a pneumatic hoist, and everything is arranged so that when it goes through the floor, it just comes above the point to which the chassis frame and front axle have been moved. Thus the engine is carefully let down into the frame, and simultaneously the back axle is moved into position, the transmission is coupled up, and the rear springs are connected to their shackles at the same time. The time taken for this operation sets the time of the flow production system throughout the whole of the factory. The average duration required for the operation is 2 minutes, so that the whole factory at Cowley operates basically on a 2-minute schedule. You get a very good view of all 4 assembly lines and overhead feeders. One line on the right is dealing with the miners, the middle one looks after the 10 and Cowley models, and the left-hand one is where the majors and Oxfords are built. Conveyors are not used on these lines, the men being given plenty of time to carry out their operations and then to push the chassis by hand on its dummy wheels to the next station. It is a marvelous scene of beautifully organized industrial activity. There is no sense of rush or bustle. Every man seems to have plenty of time to do what he has to do. There is nothing skimped, and as a result, the quality of the work as well as the quantity turned out is extraordinarily good. As an example of well-timed sequences and dovetailing operations, it is most impressive. At the end of the chassis line, the chassis as a component is practically complete, for its dash, radiator, and other important parts have been fitted, together with all petrol pipes and so forth, and it is pushed off the main line onto a transver, which takes it sideways so that it can be routed through into the spray painting booths immediately it has been assembled. These booths are extraordinarily interesting devices which ensure that every necessary part of the chassis is properly covered with protective enamel. The chassis is clamped down to what I can best describe as a tumbril, and this rotates completely over sideways so that the men with their high-pressure guns, which spray the protective liquid onto the chassis, can reach every part, particularly those which we normally regard as the underneath of the car. It is a very strange sight to see a car chassis being turned completely upside down, slowly revolving, while the two men see that every vulnerable part is properly protected with enamel. As an example of thoroughness in manufacture, this must surely be very effective, and I believe it is unique. It must also help to make for longevity on the road in the hands of the private owner. In the meantime, in another part of the factory, the Dunlop tires are being extraordinarily contented. There is no suggestion of sweated labor. They work hard, but very happily. After the tires and tubes have been fitted, they are inflated from a main supply of air at the correct pressure, and the wheels are then placed on a very ingenious conveyor which hoists them up to the roof of the shop, whence they run by gravity down a long chute to the point at which they meet the chassis. Since we last saw it, the chassis has come from the spray painting booth through a heated tunnel in which the enamel is thoroughly hardened and dried, and has arrived at a point at which hydraulic rams sunk in the floor lift it up and enable 4 men, all operating at once, to put on the protective washers and then the road wheels with their tires. This operation is carried out at this stage so that the new wheels and tires do not have to go through the heated tunnel in which the enamel is dried. The chassis is now nearly ready as a roadworthy unit, and it is thoroughly greased and filled up with petrol, oil and water, and taken on the road by an expert for a long, searching test. When it has passed this test and has undergone a careful inspection and final tuning, it comes into the wiring department, wherein all the lamps and the other electrical components are fitted and wired up, together with the mud guards and the running gear generally. It is fitted up with these components after it has been on road test, so that there shall be no fear of damage to them, for at every stage great care is taken in all Morris factories to see that both the internal and external quality of the finished product is of the highest possible order, and that the customer obtains the maximum value for money, which means ultimate satisfaction and commercial prosperity to the factory and the organization as a whole. So that, then, is how they make the chassis of the car, the part that very few motorists see, but on which they all rely. And I must say they make them extremely well at Cowley.
Yes, as opposed to a man, all that sort of thing is quite interesting. But if I went to see a car made, I should want to know all about the bodywork, see how the upholstery and the windows and things are put in.
Do they employ girls to make up the seats and cushions, or is it all done by men?
Oh, no. In the upholstery sections, you'll find literally dozens of girls doing the sewing and all the other things that women do so much better than mere men. You see, the body of a car really starts its life in what they call the sawmills, where huge stacks of timber are rapidly but very accurately cut up into the necessary sections for the framework of the body. Only the finest, well-seasoned wood is used, and in the sawmills, one's first impression is of extraordinary cleanliness. On all sides you see extractors which take away the sawdust and the fine shavings that come off the wood that is being worked upon, and some of the machines really are most ingenious. In practically every instance, the wood is cut up in a series of accurate jigs, and you see dozens of expensive vertical spindle millers with pieces of wood in jigs or guides which bear on guards top and bottom, so that the correct shapes are formed. Then again, very rapidly working planing machines are utilized. And on other vertical millers, the various sections of the bodywork are cut out with a great deal more accuracy than one normally associates with woodworking instruments. The way in which some of the men in the shops use band saws and follow the markings on wood that has previously been jigged out is truly remarkable. It looks extraordinarily dangerous, but accurately it is not so. From the sawmills, the finished parts are taken into the body assembly shop, where a great deal of manual labor is used. The parts are put together, again in accurate jigs, where they are carefully glued and tightly screwed together, and it is most interesting to see, for instance, the body of a Morris Cowley saloon being assembled. The sides are first of all attached to the platform of the body, and then the roof or canopy is put on, and after all the joints have been securely made, the beautifully evenly pressed steel panels forming the tonneau of the car are fitted. There is on every side plenty of evidence of the accuracy with which all the work is done, because there is practically no fitting required to obtain an extraordinarily good finish. In the body shops, the principle of flow production is, of course, again utilized. Each man has a particular job of work to do, and when he has done it, the body is pushed along to the next station. When all the steel panels are on the wood framework and the doors have been hung, the panels are carefully and thoroughly cleaned, and after that they receive their first coating of cellulose, which is known as the undercoat or primer. This is put on, as are all the other coats, by a rapidly operating spray pistol, which gives a beautifully even distribution. Immediately it has been painted, the body is pushed into a huge high-temperature drying tunnel, and it stays in this tunnel for some 9 hours or so, emerging from the other end to receive yet another coat of primer. After 4 coats in all of primer have been given, and each one separately dried, the body is rubbed down by hand with lashings of water to obtain the foundation of that beautiful smooth surface that all Morris cars possess. This rubbing down by hand is one of the few operations that cannot be done by machine. When it is finally flatted down, has been washed perfectly clean again and dried off, the color coats of cellulose are sprayed on. This is done in very much the same way as with the original primer coats, and it is interesting to observe that 4 coats of color are given to every body, which is then dried again between each coat in a heated oven, and thereafter is rubbed smooth by hand, another operation that cannot properly be carried out by any machine. There is no doubt that the amount of care and labor that is expended on Morris coachwork is very great indeed. But almost equally interesting as the bodybuilding shops are the upholstery shops, where some of the young ladies that you were inquiring about can be seen at work. Of course, not all the work is done by women. Such arduous processes as cutting through many thicknesses of upholstery material at once with electric knives is done by men, and it is most fascinating to watch the accurate way in which they work. But when it has been cut, the material is all sewn together by women, and the speed and accuracy with which they work is truly remarkable. Yet, although they are working hard, they never give one the impression that they're overworked, and there is an atmosphere of happy contentment in all Morris shops which is really extraordinarily pleasant to see. If you watch the young lady whose mission in life it is to sew pleats into the upholstery material, you will see that she works with uncanny accuracy, but when she has made the pleats, they are filled with stuffing in another part of the works in a most ingenious manner, a big tube used as a needle pushing the stuffing through the pleats, in which it is retained on the return stroke. A harder work, such as this, of course, is done by boys or young men, and not by women. Everywhere properly graded labor is arranged in the Morris works. And a general view of the upholstery departments is extremely interesting. You can see all the cushions and the back squabs of the seats for the cars being made up with ample quantities of stuffing material to make them supremely comfortable, and all the way up the work benches you see evidence of the cheerful spirit and the keen way in which all these Morris operators handle all their work. But come back to the body shops once more, and let us have a look at the finishing line. All the bodies are mounted on trestles which have wheels under them, so that they can be moved from station to station. And on these long lines you see the body gradually develop from an unfinished shell to a complete and upholstered specimen of fine coachwork. On these lines, the triplex glass windows are put in, and all the cushions, and all the trimmings, and then, at the end of the line, the body meets the chassis, which has been brought to it on what is called a transver, which moves it sideways across the shops so that the appropriate chassis can be matched up with the proper body. When it is completed and finally inspected, the body is lifted onto the chassis, and this is known as the process of mounting. The body, because it has been carefully and accurately made on jigs, drops squarely and fairly onto the chassis without any necessity for fitting or adjusting. Other chassis have their bodies brought to them from an overhead storehouse in which the bodies from the Coventry branch of the Morris Motors factory are stored. I saw them mounting a beautiful sports coupe, while large quantities of chassis flowed past across the shop on the transver. A very interesting sight indeed. After being mounted, a final polish with a rapidly revolving buff is given to the body, and the degree of gloss that is obtained on the cellulose is very delightful to see. It is hard, long-wearing, and lasts practically forever. A very fine coachwork finish. Then, on the final finishing line, the bonnets are fitted, and all the seats are put in, and all those final adjustments are made that mean so much to the owner of the car. At every stage, practically, along these finishing lines, the body is very carefully inspected, and not until it has passed the eagle eye of many inspectors is it allowed to go forward off the end of the finishing line into what is known as the final test department. You see, every Morris car is given two separate road tests, one as a chassis and one as a complete car. The finished car is taken out onto the road by a highly trained expert for final approval, and when passed off, it is taken into the dispatch department, a finished product to await delivery. And there they stand, spick and span, all ready to be taken away to their purchasers. And I must say that from what I saw myself, they're immense value for money. You can't go wrong buying a Morris.
Well, that really is most interesting. It's almost as good as seeing it for oneself, don't you think?
Yes, no wonder you were thrilled. But you must be very tired. Will you have a drink?
Thanks very much. Yes, it was a little strenuous, but I must say that I had my eyes properly opened at Cowley. Allow us to introduce Mr. Alan N. Cooper, one of our more adventurous Morris owners. Mr. Cooper drove this Morris Minor two-seater car all the way from Nairobi in East Africa to see us at Cowley, and his trip was a complete conquest of the Sahara and a vindication of the powers of his car. Mr. Cooper, who is a coffee planter in Kenya, had as his constant companion on the journey Jacko, his pet monkey. Jacko came with him all the way, and what an adventurous trip it was. The route lay over 8,500 miles of the most varied going, from near the equator, and it was a particularly severe test across the arid wastes of the Sahara Desert. The little car was not accompanied by any others to carry the luggage, and therefore all the bedding and the cooking equipment had to be stowed away or carried on the running boards as best it could. Some of the food containers were made of skins of wild animals, and cooking utensils almost as primitive served their daily purpose. A big drum of drinking water for the driver and his passenger, not for the engine, for that never once boiled, was mounted on the running board. And on the tail of the car, a collapsible camp bed was carried. This standard Morris Minor, by its conquest of the Sahara and its subsequent long, successful overland trip, surely sets the seal on the renoted reliability and staying power of its type. This is how they train the Oxford and Cambridge boat race crews nowadays, not from the towpath, but from a fast launch on the water. Here is the Oxford crew being coached near Henley from a six-cylindered Morris-engined launch prior to the great race at Putney. The secret of training a good crew is to get every man to work in harmony with his fellows. Just as in the case of an engine or a car, all the parts must work in constant harmony with the other component parts. Golden Vanity, which is the name of the Thames-built launch that was used for carrying the experts and coaching the Oxford crew, has a useful turn of speed. It needs to be fast and steady, for an 8-oared racing crew in their narrow shell can sprint up to 10 miles an hour or more. So now then, you fellows, pull away and get some pace out of that boat. And let's see if this year Oxford can't break their long series of defeats and once in a way win the boat race from Cambridge again. Visitors are always welcome at Cowley to see how Morris cars are made, and occasionally we get some very important and interesting visitors too. Here, for instance, is the Emir of Katsina, who last year was shown the more important sights in England by the government. That was to impress him with the state and efficiency of our highly developed civilization. I wonder if they showed him our income tax returns. But as a leading unit in a big industry, Cowley was chosen as the most impressive, and the Emir certainly seemed very interested indeed in all that he saw. After going through the chassis erecting shop, where the machinery and various intricate processes greatly delighted him, he walked up the long lines of the body finishing department and took a keen interest in the way in which the upholstery is fitted and shaped down, and all the various final components of the cars are put together. Despite his age, the Emir is distinctly sprightly, and he's most intelligent. Certainly, he's not one of those people who object to being photographed. Whenever he sees a camera, he's perfectly happy to look pleasant and let himself be shot for as long as anyone seems to think necessary. After he had been through the works, we showed him the performance of a six-wheeled, six-cylinder, cross-country car that is made in one of Sir William's factories. See how she climbs, going practically over any old kind of country, up steep hills and down deep dips. Surely a good vehicle for his native Katsina. His Highness was voluble in his praise, especially as he used Morris cars personally on his visit to England. At the conclusion of the day, he and his entourage were greeted by Sir William Morris. The Emir expressed himself very interested and, indeed, amazed at some of the things that he saw. We had the pleasure of presenting him with a small souvenir of his visit, and that he was pleased with it, there seemed to be very little doubt. And does the Emir like a camera? In order to assist the British Hospitals Air Pageants Committee, who were collecting funds for hospitals last season, Sir William Morris donated several Morris cars and Morris commercial trucks as transport for the air circus that toured the country all the year round. Here you see Mr. C.W.A. Scott, the holder of the Australian England air record, taking off with his machine to give the crowd a thrill. And here's the circus in formation. It travels from place to place, giving a new show of stunts, passenger flights and thrills every day, and thus impresses the native populace with our conquest of the air. Now see a live parachute drop. There are many ways of earning a living, but to be a parachutist would not appeal to quite a number of people that we know. You see, the parachute man has to gauge his jumping position relative to the aerodrome so that the wind drifts him back the way he came from. It's not so good to land in a tree. You might think that some of these excellent people were qualifying for admission into hospital instead of endeavoring to collect hospital funds. Here is a man gaily riding on the wing of an aeroplane, apparently with no visible means of support. And he even stays in that hazardous position while the machine lands. Well, it takes all kinds to make a world. Not only on land, but also on water, the products of Morris Motors are to be found daily doing their work reliably and well. Here is a Morris engine fishing smack going out at dawn to trawl many miles from the coast. This is how the familiar fish get to your table. The men are putting down the long, heavy trawl that is towed behind the vessel when once she has got out to the fishing ground. In fine weather, it's not bad work. But when the seas are rough, it is by no means anything but an arduous task. The craft gets out to the fishing ground under motor power. But then, after the trawl has been let down, she trawls under sail power, as there is no point in making much speed while the trawl is in the water. After it has been down for some time, and if it hasn't caught any rocks or snags, they pull up the trawl again. And this is the back-breaking work. You may think that sailors don't care, but you can bet your sweet life that they care about this. For it's their livelihood, and their wives and their families too all depend on the contents of the trawling net. Sometimes they get a good catch, but more often it's a poor harvest with unedible fish, crabs and shrimps and fleshers and other unsaleable denizens of the deep that have no market value at all. It's a hard life and not a particularly enjoyable one, but it's easier than it was, for the sturdy Morris four-cylinder engine tucked away beneath the hatches quickly and smoothly drives the ship back home again once she has left the fishing ground. And the reliability and safety with which the engine functions must be a great comfort to these fisher folk. This is sports day at Cowley, and all kinds of tastes are catered for. There are hurdle races. Then they have long and short distance cycle races. There's also running and jumping. Even the stenographers come in for the short sprint races. An interdepartmental rivalry is heavily promoted by the relay events. But one of the most popular items is the tug of war, when the strong men from the transport and sheet metal departments endeavor to gain victory over each other by sheer brute strength. The knockouts of the various competitions take weeks to work off, as many teams compete from all sections of the works. Now then, boys, heave away. Lie well, backs up. Come on, stick to it, stick to it. Oh, well pulled, sir, well pulled. And at the end of the event, Sir William and Lady Morris distribute the prizes. And every endeavour is made at Cowley to keep the employees happy so that they can turn out the best possible work. When the question of car storage has to be considered, why not think of the motor houses that are sold by Morris Motors Limited? These are specially constructed so they can easily be erected in little more than a fine afternoon, or a wet one for that matter. Every part is marked out and ready drilled so that the structure goes together with the minimum of trouble. After the concrete base has been laid down, the steel framing is put into position. It's all screwed together with the bolts that are provided, and as you can see here, the assembly is not particularly difficult, providing the proper instructions are carried out. Being made of steel and strong asbestos sheeting, these houses are fully fire resisting and will last for many years of ordinary use without particular care. Plans are provided for submission to county councils, and this facilitates permission for erecting. It's not a bad way of saving money, this, putting up your own garage. And there are, of course, various different types at different prices for the sizes of car that it is required to house. A special feature is the roller side doors, which, by the way, cannot blow open or shut in a wind, and they need no external room to swing. These motor houses are sold at prices that range from as low as £10, and they certainly represent an interesting addition to the car-using facilities that Morris Motors provide. When you see a Morris car running smoothly and quietly down a pleasant highway, do you ever wonder how many parts there are working away inside the engine? It needs very careful and accurate workmanship to obtain the degree of silence that is required in a modern motor car, and such silence is only achieved by the utilization of extreme accuracy. To make it clearer, have a look at an engine on a test bed and see all the important parts, the pistons, the valves, and the tappets in motion, and realize that all these and many other parts are constantly in operation whenever the car is moving, some revolving, others reciprocating. Now bear in mind that for the sake of your economy, most of these parts and others are made on rapidly operating semi-automatic machines. You naturally wonder how the necessary degree of accuracy has been obtained. In the Morris factories, accuracy of machining has been brought to a very high art indeed, and it has also been coupled with rigid economy. In other words, efficiency in Morris machining is paramount. Take, for instance, this semi-automatic machine that drills valve guides and accurately reams them out to their proper size to within 1/1000th of an inch limit. It feeds itself automatically without attention. The operator simply fills the hopper, and the machine itself does all the rest, brings the tools as required into operation in the correct sequence, and because the tools have previously been set to the required dimensions, automatically ensures correct length and size of cut. Here again is another example of high-speed operation, tapping many holes with threads at once, thus saving time. But when the parts so made come together, they must fit with extreme accuracy and work perfectly freely. This is a gearbox being assembled. See with what ease the various machine parts fit each other after they have been made. In itself, this is proof of the accuracy that has been obtained in the process of manufacture. All the intricate components fit each other snugly and with that high degree of correctness that not merely ensures speed of assembly, but also is in itself proof of long life and silence, in other words, of satisfaction to the buyer. And the engine and gearbox, before being sent out to the erecting line, have to pass with flying colors a test for a very high degree of quietness, and they are tried out both on the dynamometer bed and on the road before being sold to the motorist. So let us show you some of the apparatus that is used to obtain this accuracy. Here we have a representative selection of the various delicate instruments that are utilized in the laboratory and tool room of the Morris Engines factory at Coventry. They cost many thousands of pounds and are capable of measuring or weighing to very fine limits indeed. Now, all these intricate and costly gauges have as a fundamental basis what is known as the standard slip gauges. These are very, very accurately made lengths of hardest steel, very expensive, and guarded as carefully as is the British government standard yardstick. Observe in the first place that these gauges are not magnetic. They do not attract each other. We will try to show how accurate they are by a simple but very convincing experiment. The operator is taking a number of the slips, quite dry and clean, and is simply pressing them together. He slides one surface onto another, and thus is going to build up a little structure to show you that because these gauges are so accurate when they are slipped together, as you see now, they absolutely exclude all air from between their surfaces, and thus actually are held together by atmospheric pressure alone. You will see that one side of the figure that is being built contains a number of small slips. The other side consists of one large gauge of an equal total dimension. The operator forms a kind of cross with a connecting piece top and bottom, and if there were any lack of accuracy in any of the 10 gauges used, even to the small extent that would let air in between their faces, he would certainly not be able to lift them up as he does with a piece of string, showing the extraordinarily fine flatness and phenomenal degree of accuracy that they possess. These gauges, then, are the fundamental basis of all the measuring devices that are used in the factory. From them, the production gauges are made, and here you see a grinding machine in the tool room making what is known as a gap gauge. The grinder is taking a very fine cut, and after each operation with this extremely accurate machine, the actual gap between the jaws of the gauge that is being made is carefully measured by using one or more of the slip or master gauges that you have just seen demonstrated to such a very high degree of accuracy and which are the factory standard. The operator uses the requisite number of gauges to build up the correct dimension, and these must fit snugly without any shake at all in the jaws of the gauge that he is making. Then this is another example of the way in which the slip reference gauges are used. The machinist here is making a jig for boring a component part of an engine, and he wishes to check accurately the distance between two holes. He inserts tightly fitting plug gauges into the holes, and then, by making up the requisite dimension with other slip gauges, he checks accurately the distance between them, again ensuring that the gauges just snugly fit. Now let us show you by diagram the principle of the gauges that are used in the machine shops. You will quickly understand that if you have two firm jaws, say 4.5 inches apart, and another two jaws 4 inches apart, and an object will go inside the 4.5-inch jaws but will not go inside the 4-inch jaws, then that object must be between 4.5 and 4 inches in length. In actual practice, the difference between the two sets of jaws is only 0.005 of an inch, which means that if a part that is being gauged will go in between one set of jaws but will not go in between the others, it must be accurate to within 0.005 of an inch. These are some of the actual gauges, two external gap gauges, and a plug gauge which uses the same principle, one end being 0.005 of an inch larger than the other. Then here we have a dial gauge, commonly known as the clock. See for yourself how much the pointer turns when it is measuring such a thin substance as the thinnest piece of cigarette paper. pull a hair out of your head and pass it under this dial gauge, and you will see that the pointer jumps as though it were passing over a piece of rope. Most people's hair is about 2/1000ths of an inch thick. Then this very accurate gauge depends for its principle on a column of fluid in a glass tube, at the bottom of which there is a flexible vessel with a plunger. When a part to be measured is passed underneath the plunger, it shoots the fluid up the tube, thus multiplying the dimension. And you can see the column of liquid in this close-up varying according to the minute variations in the parts measured. This instrument measures to within no less than 1/100th of a hair's breadth. So come back now to the production shops. Here you see a semi-automatic machine turning out valve spring retainers. It feeds itself and brings the tools into operation as required. It is extremely accurately set up in the first place, but every part that it turns out is minutely but rapidly gauged by the means that you have just seen. The operator who watches the machine has by him a complete set of gauges, a plug, go, and not go gauge, which shows that the central hole is within certain extremely fine limits, and similarly, he has other gauges to check up on the other dimensions. Every part is gauged all over. In the making of these production gauges, extremely accurate machines in the tool room are utilized, and all the finished surfaces are hardened and ground so that they will last for long periods with absolute reliability. This operator is using micrometer and is working with it in the tool room, making a plug gauge to be used in the production shops. This particular gauge is used in this manner. Watch the center of a gear wheel being ground. The grindstone recedes and is trued automatically by a diamond. Then it feeds itself into the center again. Before the job is removed from the machine, it is carefully gauged with a go and not go plug gauge, which must fit perfectly. See now how the spline gauges are manufactured. The splines or parallel grooves being parts of the gears in your gearbox. Every dimension, both for breadth and height, is very accurately checked. And when this particular gauge has been made, it is used to ensure perfect accuracy of the hole that is broached in the gear wheels. This next interesting operation shows how a splined hole is formed inside the gear wheel. The long castellated cutting bar that you see going from the right to the middle of the picture is drawn by power through the gear wheel, thoroughly lubricated all the time, and gradually it develops a series of splines or parallel recesses through the center of the wheel. It is on these surfaces that the gear slides on its spline shaft as you change gear when you come to a hill. Now you can see the actual castellated formation, and here the same principle is used with a go and not go gauge to check the width of the splines as well as their inside and outside diameters before the component is passed off as suitable for assembly. It is only by these extremely careful methods that Morris quietness and reliability can be obtained. Now see another example of the way in which money is saved in a modern, highly developed production factory by the employment of specially designed and cleverly constructed machinery. The 6 round objects that the operator has just put on this machine are blanks for skew gear wheels in a Morris engine. You will see as this operation proceeds that they are all cut at once, thus enabling maximum economy in production to be achieved. The minimum of time is taken, and concurrently, the highest possible degree of accuracy is obtained. The 6 blanks, when bolted up together, form what is apparently a solid drum. The cutter can be seen at the bottom of the machine. It rotates and traverses sideways. As it cuts into the metal, it generates perfectly formed spiral gear tracks of predetermined width, shape, and depth. In order to show you this process clearly on the screen, we have speeded it up photographically. As you can well imagine, the actual operation takes a great deal longer than it does for us to show it to you. Actually, the complete cut takes about 20 minutes from end to end, but in principle, the operation is the same as you see before you. Now, as it is nearing its end, you see that there is formed an apparently complete drum of gears. But you will observe that as the operator unloads the machine, there have actually been made 6 perfectly cut and finely finished gear wheels. This is simply one ordinary example of what is commonly known as flow production. It is a time-saving principle which also gives the highest possible accuracy. But even so, at the end of the operation, each gear wheel is individually checked for accuracy by the micrometer clock that you see on the right. If there were more than 0.02 of a millimeter variation in the readings as the wheel rotates, it would be rejected. As it is, the variation is very small indeed. And here is what is known as a master cam. The cam form, which, after experimental work has been done, is used as a pattern for making the other cams for the engines that you buy. In the actual making of this master cam, no less than a month's work is entailed. The operator here is working a grinding machine in which the degrees turned on the cutting face are shown enlarged through an eyepiece in the optical head. This enables extreme accuracy to be obtained, for, as you can imagine, unless the rise and fall of the valve in an engine is extremely carefully controlled, not only will lack of power result, but also the engine will be noisy. Observe with what meticulous accuracy the operator is working. The slightest slip would spoil the job. From the master cam, when finished, there are directly developed other cams which are used in the grinding of the actual camshaft that goes in the engine. This is done on a semi-automatic machine, but the accuracy of it is naturally a direct reflex of the care that was taken in the manufacture of the original master inlet and exhaust cam. Now, when dealing with gear teeth in such similarly small shapes, it is frequently necessary, for the sake of accuracy, that the actual shape of the part be checked up by what is known as the enlarged shadowgraph method. This operator is carefully stoning the master shape for a chain wheel tooth. You can see that these two parts fit so accurately that no light at all shows between them, thus proving that to a very small fraction of an inch they are dead accurate. And then again, in order to ensure accuracy in threads, the shadowgraph principle of this type of machine is used. It throws a very much enlarged shadow of a thread of a screw or any similar object onto the screen, enabling its formation to be checked against a standard diagram or to be measured. But not only in the machining, in order to ensure the long life and reliability of the motor car, heat treatment of metals is a most important process. Heat treatment determines the character of the finished part insofar as its toughness and surface hardness are concerned. Huge oil-fired furnaces are maintained rigidly at very high temperatures. Small parts, such as gudgeon pins, tappets, and so forth, are placed in bins together with the hardening compound, and after having been in the furnace, are extracted after a certain time has elapsed, careful control being maintained over them at all stages. In other furnaces, where the intense heat makes you conjure up a vision of Dante's Inferno, camshafts are heated to the proper temperature for the correct length of time. Immediately that time has elapsed, the furnace doors are opened, and men, almost stripped to withstand the intense heat, grip the parts in insulated tongues and plunge them into hardening baths of special whale oil. A false floor to this bath is continuously moving so that a free flushing of fresh oil is available for every particular part, and perfect distribution of the cooling effect is obtained. This means that the parts are thoroughly toughened inside and are hardened on the outside. The temperature of the furnaces is maintained constant by these pyrometers, and the little fingers that look like Mickey Mouse on the screen show both the temperature to the controller and give a permanent record on the chart as well. One master pyrometer is provided to show immediately the temperature of any one of 12 separate furnaces. It gives a rapid reading and enables complete control and constancy of temperature to be maintained. The result of case hardening is that you get a tough core of metal with a hard bearing surface on the outside, as is plainly apparent in this example of a Morris camshaft that has been deliberately broken to show the case hardening effect. Now see by what extremely ingenious and yet very accurate machines the Morris pistons are made. Everybody knows that the piston is a very important part of the car indeed. It reciprocates up and down the cylinder many thousands of times a mile, and if it were not accurate, would cause loss of power and very extraordinary noises. What in this instance looks rather like a huge rotary aero engine is actually a machine which never stops during working hours and enables the gudgeon pin holes in 2 pistons to be machined at each operation. The operator loads the top stations while those underneath are being dealt with, and on the lower part of the machine there are 2 drills and 2 reamers operating simultaneously on 4 pistons. This machine, like the others we have seen, is semi-automatic. The actual cuts of the tools are definitely set to very fine limits. And here is one of the finest examples of accurate machining that the automobile industry of any country knows, turning metal with a diamond. A tool at the back of the lathe takes off a fine cut with an ordinary steel cutter, and then a tool which has an actual diamond for its point and is nearest to you in the picture puts on the finishing cut. As it travels along, you can see the extraordinarily fine finish on the piston being developed. This gives a beautiful surface that is smooth running, silent, and long-lived when the piston is ultimately fitted to the engine, and the high degree of gloss that is imparted and the fine working surface is well illustrated by this extremely accurate reflection of any object that one gets off the surface of the piston after it has been diamond turned. But not content with this extremely high standard of machining, every piston that goes into a Morris engine is carefully gauged and graded by experts before it is passed for assembly. Every piston is selected against the cylinder bore in which it is going to operate, and it is only by such means as this that the ultimate satisfaction and high quality that is demanded by Morris engineers and which is passed on to Morris owners can be obtained. You can see that when the engines come to the assembly bed for their final erection, they go together in a manner that is in itself proof of the extremely high standards of accurate workmanship that are employed. All the parts match up with each other strictly in accordance with the original desire of the expert designer, and this too means a saving of money and time to the owner, for it means that in case of road accident, replacement parts that are sold by Morris Motors can be relied upon to fit immediately. And last we will view the finished engine giving off its full quota of power on the test bed with that beautiful rhythmic murmur that is the criterion of a perfectly made piece of mechanism. These marvels of modern machinery give you, we hope, some insight into why your Morris car runs so smoothly and tirelessly along the road. A triumph of engineering, a tribute to the genius of the founder of this wonderful Morris organization, and a credit to Britain the whole world over.